All right. So here we have the graph of r equals 3 cosine 3 theta. And you notice that our n value, is an odd one. And since it's odd, it's with cosine. That means it is symmetric over the x-axis. Since it's cosine, it's symmetric over the x-axis. Since this number is odd, this here, and it's cosine, it's symmetric over the x-axis. Again, since this is odd, since our n value is odd, we have 1, 2, 3 petals. And our radius, or the r, or sorry, it's not radius, it is the, if we go back to our slides, it is the a value. The a value is 3, which means our petal lengths are 1, 2, 3 units long. So again, it's an odd n, which means it's symmetrical over either the x or the y. Since it's cosine, it's symmetrical over the x. Since n is odd, we have the same number of petals as n. So we have 1, 2, 3 petals. And our a value is 3, which means the length of the petals are 3. Here we have 4 cosine of 2 theta. And our n value, notice, is, I'm going to zoom out a little. Our n value is 2, which is an even number. Since n is even, it's symmetrical over the y-axis, it's symmetrical over the x-axis, and it's symmetrical over the origin. So since n is even, it's symmetrical over the the 2 axes and the origin. Since n is even, that means we have 2 times as many petals. So 2 times 2 is 4, so we have 1, 2, 3, 4 petals. And since our a value is 4, each petal has a length of 1, 2, 3, 4. 1, 2, 3, 4. So again, we have an even n value, which means it's symmetrical over the y-axis, x-axis, and the origin. Since n is even, we have twice as many petals. So 2 times 2 is 4. And our a value is 4. You can see if I change this to be 4, we'd have 1, 2, 3, 4, 5, 6, 7, 8 petals. So if we have an even, it's double the petals. Here we have odd, an odd n, and it's sine. So that means we're symmetrical over the y-axis. So you can see if we made a fold right here, all of these, this side would match up with the left side. Since our n value is odd, we have 1, 2, 3, 4, 5, the same number of petals. And since our a value is 3, each petal has a length of 1, 2, 3. So again, we have an odd n and sine, so that means it's symmetrical over the y-axis. Since we have an odd n, we have the exact same number as our petals, as the n value, so 1, 2, 3, 4, 5. And since our a value is 3, each petal has a length of 1, 2, 3. Here, again, we have our n value is even, which means we are symmetrical over the y-axis, we're symmetrical over the x-axis, and we're symmetrical over the origin. Since our n value is even, we have twice as many petals. So 2 times 2 is 4. 1, 2, 3, 4. Again, if this was 4, we'd have 1, 2, 3, 4, 5, 6, 7, 8. And our n value, or excuse me, our a value is 4, which means each petal length is 4. So from here to here is 4 units. from here to here is 4 units. Now you can kind of see the difference between a sine and a cosine function. The sine, the petals are inside the quadrants. On the cosine, the petals are on the axes. Here, it's not, the pattern isn't as noticeable for the odd ones. For even, the petals are on the axes or in right straight in the middle. Or let's see if this is 8. You can see that it's all 1, 2, 3, 4. 1, 2, 3, 4. All 4 are in the middle of the axes. So that are the different Rose curves.